Hello, I've gotten some emails from students that they're trying to figure out the capacitor equations a little bit more. So I wanted to record a quick video to try to help you with these. The first one here, I sort of think it makes more sense to me if I rearrange it slightly by multiplying both sides by C. So I end up with C delta V is Q. What's this telling us? Well, imagine I hook these two capacitors up to the same potential difference. So this battery is going to start pulling electrons from the positive plate and pushing them to the negative plate. So what happens there? Well, we start removing electrons from here and from there. And that means that positive charge is going to start growing in here. Now, think about how energetically favorable it would be to concentrate positive charges together. They really don't like being near each other. So if you suddenly had an object and you had to concentrate tons and tons of little charges on it, that's going to be hard to do because you've got positive charges so close, pulling the next electron off is going to get harder and harder. But you could have the same number of positive charges more spread out, and it won't be that hard to take them off. So basically what's going to happen is we're going to end up with more positive charges on one capacitor than on the other. And of course, we'll have the same negative charge on the other plate. So what this equation basically tells us is this tells us how, for any potential difference, we can figure out the charge. So the charge that gets stored on a capacitor depends on this thing called capacitance. Okay, so this is the thing that determines capacitance. We've already seen that having a larger area of plates means we can put more charges on there with the same potential difference. So the area of the plate, not surprisingly, is directly proportional to capacitance. The electric constant, the permittivity of free space, that essentially tells us how a charge affects the space around it. So essentially, permittivity of free space ultimately is telling us how strong the electric field is going to be inside a capacitor. We also saw in the FET lab you guys did that separating the plates, the more they're separated, the less capacitance we have, the less charge seems to be able to be held for a particular potential difference. So the only thing is this K. What's that? It turns out that if you put other materials in there, you can actually put more charge on these plates, but have the same electric field. Because the electric field doesn't spread out, the electric field isn't as strong in these materials due to these larger charges. So essentially, you could put different materials in there and increase the capacitance. Every material that we use in here has a different value for the so-called dielectric constant. That's typically something you'd be given or you'd look up in a table. Okay, these two equations, what's up with them? Well, if we have a capacitor, we hook it up to a battery, what happens? Well, electrons start to flow. We do work to move electrons from one plate to another. The potential difference between these plates at first, because they're uncharged, is 0. So we could say VO is 0 volts. But as you start to rip electrons out, it starts to become harder to do that because this potential difference starts to rise. And another way to say that is the more electrons you take away from this plate and stick on that plate, you're taking more and more electrons away from where they would naturally be and putting them where they really shouldn't be, close to other negative charges. So that's going to require work. We're going to have a final potential difference of whatever the battery voltage is. So what's the average it's 0 plus VF over 2, or 1/2 VF. So at the end of the day, this equation comes from our standard potential energy equation. We have the charge Q, which in this case is going to be the charge on the plates. But the V here is going to be V average, which is half the final potential. That's where that comes from. Where's the other one come from? Basically just plug in there and you get that. So I hope that helps with the capacitor equations. Just get in touch if you need any more help.